Well, welcome everybody. Appreciate you coming. I know late in the day and the conference is nearing an end, you get tempted to play hooky, so appreciate you coming. I'm Dave Rotman. I'm Chief Information Officer at Cedarville University. This is Tim Kelly, our network engineer.
How you doing?
And we'll spend these next few minutes together talking wireless. I'd like to get an idea of where you all are coming from. Any K-12 IT folks here? Okay. The rest of you higher ed, I assume? All right. How many of you have deployed 802.11ac to some extent in the process? Okay. Good. All right. Anybody supporting a one-to-one environment? iPads, notebooks, okay? One. Several, all right. A relatively new project or ongoing? Ongoing, okay. Brand new, all right, good. That's an interesting evolution as the industry has changed, and our local school district is doing Chromebooks starting in the 9th grade. This will be fun to watch. We're going to try to talk topics and issues here without getting salesy, so this may come across as a sales question, but it's really information, all right? What kind of stress points are you seeing in providing network services? Where do you think you're at risk? Where is the growth? What's happening on your network? The salesman paraphrases what keeps you up at night. I hate that question.
Proliferation of devices per user.
Okay, number of devices per user growing. I've heard figures as low as 3, as high as 7 on average. Is that what you're seeing? Lots of devices. Sometimes in a meeting I start counting, oh, there's one in the pocket, there's one in the bag, and I happen to be wearing one of these devices. Now it's Bluetooth, so it's not taxing the Wi-Fi, but it's kind of fun to have something on my wrist. And, this is a marriage saver. In case anybody has this difficulty, I would get home at night. My wife would say, "You didn't answer my text." I said, "I didn't get it because I couldn't feel the vibration of my phone. This is on my wrist, and I can feel that, and I can respond to the text. So it saves the marriage." All right, so let's talk a little bit about Cedarville University. Tim, if you go to the next slide there.
Okay.
We're in Southwest Ohio, near Dayton, Cincinnati. 3,400 students. Most of them are residential, accredited programs, and you see there are our largest majors.
Is that feedback coming from any of the rain?
You might want.
I'm
Okay. A little feedback issue, evidently.
yeah.
We have 2,600 students that live in residence halls on the campus. Thank you. About 40 buildings. Are we back? Okay. So you see the number of faculty and staff there. We started our campus-wide network in 1992. At the same time, we started providing a computer in every dorm room. Institutionally owned, it was there to run the software that we licensed, so we've been at this a while. Some of you have heard about the flipped classroom model. One of our professors was one of the pioneers in publicizing that in the mid-90s. We have gigabit internet bandwidth. If my Alt-Tab works here. Just to give you an idea of our environment, there's a picture of our campus from Google Earth. If you look around the campus, you'll see cornfields, bean fields. So we have a little over 3,000 students. The village has about 3,000 people. So very much a small college town, but a great environment in which to work. So Tim's going to take over. Oh, sorry, one more slide. Alt-Tab. There you go. Okay, so what do we want to do with our wireless network? The huge thing there is that we want to stay ahead of the demand curve. I don't like it when somebody comes to me and says, "Hey, we're out of bandwidth to this building. We need to put a new switch in today." We don't want to be in that position. So we've tried really hard to stay ahead both on capacity, but also the level of the technology, and that's why we're moving to 802.11ac. Now I think it's Tim's turn.
I'm having problems with this mic over here, so let me go to the next one here. So when we wanted to implement the 802.11 AC, we wanted to think of what is our goals here. So we were thinking of the 3 C's: cut, clear. I'm sorry, I'm thinking of diamonds. Looking at coverage, capacity, and currency. So for the coverage, we want to look at hallways, meeting areas. It is a Christian university, so we have a large chapel session that houses a little over 3,000 individuals. For capacity, we find that per access point for Maru, we're getting about, on average, 80 users per access point. So we need to factor that in too as well. So if we have 100 students meeting in a particular classroom, then we need to meet those demands. Currency, just like B, G, and N, we feel that AC is going to be the commonplace for us, and we think it's going to be a wise investment down the road. So challenges, there's always challenges. For example, Dr. Ottman, he has the Samsung Gear. So it's not just bring your own device, but wear your own device. We've just noticed just an exponential growth when it comes to devices being brought into our campus. Google Glass, that's a new one. You can get Wi-Fi on that. So we want to make sure that we meet those demands. High density and large spaces, again, we want to look at chapel versus other areas, like the cafeteria. Chapel, students come in within a 10-minute time period, and that's a lot of, it's vexing on our network. We need to make sure that we meet that demand, and we're still working on that, versus the cafeteria where you have students coming in, trickling in and out. So we find that we can meet demand a little bit better there. Okay, so we want to look at solutions here. Doug Harmon's my internal contact through Maru, and he said it best, and I absolutely agree with it. You really need to have a strong wired network. It's very easy to blame wireless, I find. But 90% of the time, we do find that it's on our wired side. It could be a server issue, radius, our authentication, anything. And so, we want to look for solutions in the matter, and why it's very important to have a strong wired infrastructure. Let's see here. We don't want to just look at the geography of the campus. We also want to look at the population. What's our student body? What's the size is it going to be, and how can we meet those demands? I just kind of wanted to go into our layout of our infrastructure on campus. We do have dual gigabit links going to each building. We have redundancy. We use VRP. So we want, through our core switches. We do have a robust authentication system, and that includes Radius, LDAP. We do tend to find that we want to look at what types of devices. We tend to see that cell phones don't produce as a strong signal as a laptop. So we need to factor in a lot in order to find a solution to the matter. Actually, I want to give this back to Dr. Ottman.
All right, so we're going to talk a little bit about Maru. We understand Maru is a good fit for us, and it would be a good fit for a number of you, maybe not for everybody, but we'll talk about some of the features. They've been aggressive on leveraging MIMO antennas. We did, as you'll see in some pictures coming up here shortly, we chose to go primarily with external antennas. At least in the testing that Maru has done, that's about a 2 dB gain for using external antennas instead of internal. And for the cell phones, other small devices, that 2 dB could be really critical. So Maru also offers channel layering. We can do a situation, for instance, in a traditional hallway residence hall. You have APs up and down the hallway. In a traditional environment, the APs hear each other, see each other, however you want to phrase that, so they'll back off on their power so as not to cause interference. Maru doesn't have to do that. We can set them all to the single channel. The access points handle all that communication accurately. All right, let's try the next one here. Now you'll see we borrowed these slides from Gary Rolfson, who's sitting up here in the front row. But Meru's been in the wireless business for about 10 years. They were a leader in 802.11n. Has some large clients. We'll show you some of these shortly. Some interesting installations. Philadelphia School District has 28,000 access points. That's quite an install. Any baseball fans? Fenway Park is a Meru environment. Okay, next. Here's an illustration of the fields or the vertical industries where Meru has gained a foothold. You see the sports arenas there. Higher ed, hospitality is a very important part of their business and growing. In the medical industry, Nationwide Children's Hospital in Columbus, Ohio, named after Nationwide Insurance, great installation there. Interestingly, Avaya has selected Meru for their internal wireless network. So inside higher ed, let's you look at some of the names up there to see who else is using Meru, both domestically and internationally. All right. You may have guessed, Tim and I different age. Sure. So, I am not qualified to introduce Gen Wi-Fi.
Yeah. So this is a reality. If you would have came to me a couple years back and brought up the acronym, BYOD, bring your own devices, I kind of not scoffed at it, but I kind of ignored it. And then last year, I was doing statistics because I'm a nerd, and I realized that we're going to be running out of IP addresses on our wireless, and it was solely on our VLAN or wireless VLAN. And so then I realized that there is a new generation of students coming in, and it's growing. And it's growing in an exponential. I remember in the mid-90s, I was excited because, the internet was kind of, getting a little bit bigger. And I remember Juno. I don't know if any of you remember Juno at all. I don't even know if it's still around, honestly. But that was my first email account. I was really excited, and getting past the, the floppy disks, and it was just great. But now we're just looking at an entirely different scenario. So that's what we're looking at, and we definitely, statistically, it's pretty much a guarantee that we're going to see a growth on this. Versus wired to wireless, I don't think students are using wired as much as our wireless now, and I really think when we see the students come in this August, it's going to be an increase here. So, and they'll eat your lunch if you don't have internet for them. They're gonna come after you. So we want to make sure that we have everything they need. Okay, so did I miss a slide here? Yeah, okay, I did. This looks like an advertisement for a particular company, but it's not. Okay, this is a how do they put it here? A sea of laptops, and possibly a couple years back it was probably half. But this is reality, and I have walked through buildings with classes, and it's the truth. That's what we're seeing. We're seeing people having laptops while they're listening to a lecture. So just wanted to share that with you real quick, that picture. Thought that was interesting. So density versus capacity. It's always a difficult topic to discuss. There's some math involved, some statistics involved, looking at the topology, geography, architecture of a building, materials. But to try to simplify this a lot better with Meru. And again, we're finding 80 users per access point. We like to try to space our access points every 80 feet. Also, I'm old school, so I do like to put in overlapping channels. In Meru, it gives you that ability. If you want to use a single channel, I use the 1611 the 2.4 gigahertz, and we've had a lot of success with that. So let me move on to the next here. Okay. Sorry about that. Okay, this is perfect. Where is density? Okay. It's for Cedarville University. A good example would be for our chapel. We have 3,000 students, faculty, staff meeting in there to hear a lecture, a sermon, anything, and it's within a matter of minutes. So if students want to bring up their Bible app or any other type of applications, they can do that. We want to make sure we give them that. Unfortunately, we're still working on that just because of the complexities of wireless. And we need to look into that. I know that there was a concern that the students, they were adamant that we shut off the wireless in chapel so they can listen. That's not true. So, when we're looking at density, we need to look at areas like that. Again, the cafeteria or auditoriums where students gather so they can have the materials that they need. So the next one, I'm going to hand this back to Dr. Rotman, and he can explain to you a little further.
Okay, I'm not an electrical engineer, so I don't know all the inner workings, but one thing that Maru does, and I'll use this analogy. Some of you may be old enough to remember network hubs. Anybody remember network hubs? As opposed to switches, okay? In a hub, all the traffic flowed together, and it was a kind of a freeway competition. Well, wireless is something like that. If you transmit from here to the wireless access point, and somebody else is transmitting simultaneously, there's a collision. The access point says, or the device detects the collision, you back off, you wait a fraction of a second, try it again. That's inefficient. And the more devices you have, the more collisions you're going to have, so you reduce the performance. Maru negotiates with the clients, and in my analog view is the time division multiplexing approach, where you give each device a fraction of time, and that lets them broadcast without a collision. So it gives you more efficient use of the airspace. Now, somebody might say, is that a standard? Is that an 802.11 something? Well, it fits within the standards. If you've been around the IT industry, understand every company fits the standards, but then they add features to distinguish themselves. So this is a feature add. Standard clients, they all work, but they get the extra benefit. So this is what we're expecting to get out of 802.11ac. I think we'll go on to the next one. So if you talk with Maru folks much, you'll get the idea they can do single channel. With 802.11ac, that means you can use an 80 megahertz bandwidth. You can do channel layering, like in a high density area, you can kind of take the combination of single channel and the 1.6.11, overlap that, and get multiples of the performance. Context awareness is a feature that's there. We're not using it at this point, but you can actually say this particular type of device or this SSID or this channel gets priority. One use case for us would be in our chapel. We have a production crew of half a dozen folks that operate all the AV while the service is going on. They're using iPads to help control some of that on their own SSID. It would be really good if they had priority so that they're not slowed down by the student who just might be checking Facebook instead of listening. Right? So, Tali just completed a performance evaluation of Maru with Cisco. Sorry about the advance there, and Aruba. I'm sure you can find this on the Maru website, but the Maru access points perform quite well in these tests, dramatically faster than the competition. So, all that theory, let's see what it actually looks like. Tim.
Well, the example here that we're illustrating is we're actually using the external antenna 832. Included in that is we're having features built into that. We're using the full 3x3 streaming and whatever features that we can implement onto that. The next one is a picture from our residence hall. And if you notice, we call that our soccer shield. Students are, playing soccer or throwing the frisbee or passing the football, so that kind of helps protect. So I thought it's kind of comical, so I wanted to show you that. We do have outdoor antennas, different types of directions, and then how we actually have that built into the antenna is we actually take off the external antennas. Let me see if we have that. Yeah, pointer. So here's an antenna here, here, and here, and 3 other on the other side. And we have a cable that we plug into lightning protection, then we ground it, and then we feed it into the antenna. So we use these for outside. If a good example is our soccer fields or softball or baseball. We've seen better days. As you look, this has been recent. I actually did not know this was going to happen until I was in the golf cart and driving by, and this whole thing was ripped off. So it happens.
Okay, so this is our chapel we've been talking about. Seats 3,400 people. Quick arrival, and all right, I used an arrow there to point to it. It's a kind of a white wall, and the access points are white. But you'll see on the side wall there, we have 3 access points, kind of going down the side. That provides coverage on that side. Then up in the balcony, this is the video control booth. The arrow there is pointing to one on this side. There's one on the front and one on the other side, so we get kind of broadcast. We also get bleed in from neighboring classrooms, so decent coverage. We still need to work in this area. We have one slated for the organ chamber, so we'll share the sound cavity with the organ. So where are we headed next? Oh, we are going to SSID configuration and a little software. Any questions so far?
Can't be concerned that the AC standard is a little bit in flux, and that the AC itself might be evolving in a year or two, and it would be premature.
The question was, do we have concern that the AC standard is still evolving? I would have said yes a year ago, but the standard was ratified late 13, early 14. So there will be some changes coming down the pike, and depending who you read, this is called 802.11 AC Wave 1. So there will be a Wave 2, Richard, a couple years out, 3 years out? 2 or 3 years out, so there will be some changes. I don't expect firmware changes or things like that to have to be done other than software upgrades. Apple's been shipping AC products for a while. Samsung has been. My phone has AC on it. So I think we're good.
Is that single? This is power and data on one line?
These are all PoE, yes.
The future is power on one cable and data on one cable.
Yes. There's been quite a discussion on EDUCAUSE LAN list about running 2 PoEs to each access point, and that may happen. We've not had to do that yet. There's still a bottleneck. If you're going to on-campus resources, that's great, but if you're going off to the internet, providing 2 gig to the access point doesn't do a whole lot of good if it's throttled at the campus entrance point. So, Jim.
Well, right here, as you see, we want to utilize all aspects of security configuration. One good thing you don't see on here is WEP, so we don't use WEP. But we do want to use our LDAP. We do have an unsecure, but through our unsecure, we want to put in a captive portal so we can capture data. So I just want to kind of show you that and what we have illustrated here and what type of SSIDs we have for. Some are hidden. Some we want to broadcast, obviously, out to people on campus. I wanted to illustrate to you a new product that I'm still learning. It's called EasyRF. It's a proprietary software through Maru. Let me see if I can bring that up here. Okay, all right. So I would kind of ignore what's down here because I need to update it. But I wanted to show you a feature that I really like. If we want to do heat mapping, without this, we'd have to actually walk around campus and do an audit to see where we're losing signal and where is a poor signal. Here, we're actually getting a live feed of how connectivity and our signal strength is actually being displayed. We have different types of, I got to move over here. Different types of options, signal loss, to how many stations are around that area, to the signal strength. That's what we're seeing right now. And what we have done is we have a gentleman that does the CAD drawings for us. So I'll get that file, I'll convert it to PDF, or I think it's a JPEG, and then I'll just place where the access points are, and then from there we'll be able to get a pretty good data. One I'm actually really interested in is we have a residence hall called West Hall, and we've had a noted issue with students not able to connect. And it's a new building. We don't know if there's any type of material they put in there. So I'm really looking forward to using that and seeing how we can move forward. It could be a channel issue. Who knows? Could be a material issue. So I just wanted to show you that real quick. I thought that was really interesting. Okay.
Okay, if you could Alt-Tab there and get us back to the PowerPoint. Good. We're good. Okay, so where are we headed from here? Tim's crew has been busy this summer. We use a lot of student help. We have about 660 access points we're replacing, and we've done 400 or so, a little over 400 to this point. Maru has also come out with a product called I call it a faceplate, that lets you take a standard 1 or 2 gang outlet in a room, connect an Ethernet cable to it, could be PoE, or you could plug it into a brick, and supplement wireless coverage or provide wireless coverage in a small area where you don't want to deploy a full access point. So if we get a complaint that coverage is spotty in a little area, it'd be cheaper to provide this little faceplate than to put a full access point in. So we're looking forward to testing that a little bit and hoping Maru prices it accordingly. So we do need to work on our capacity. Something I'm still learning about, and I know we've struggled with Bonjour. Anybody else worried about that? Apple is not on my good list for behaving well. But we sat through a presentation on software-defined networking, and I think you'll see some resolution to those issues coming out as the policy enforcement moves out of the wireless controller, the switches, into a higher level software controller. That software controller then can handle things like Bonjour, route the traffic appropriately while blocking broadcast storms. So I'm looking forward to that. For us, it's not going to be next week, next month, but sometime soon, we hope. So that's kind of our story on Maru and AC. You have some other questions or comments? Yes, sir. It's the MC6000. We have 3 of them active, one in an N+1 failover. We didn't really look at that at this point. If I were a new customer, I certainly would. And if we were upgrading, I'd certainly look at that.
To me, the benefits of the MC6000 is that everything's pre-built. All we have to do is put it in there, and that's, to me, was a big plus. Virtualization's great, but if it's just not configured correctly, especially with all the data that's coming through there, it can go south pretty quick.
In this project, did you just pull out old access points and put new ones in the same area? Did the project incorporate we might need more access points or fewer?
We did. We're still going to look at that. We're just replacing what's there. We're hoping that that's going to be a lot stronger signal. We are finding that there is an improvement there, but we're really not going to know until we get some really good numbers.
What did you have previously?
We just had various Maru access points, so the three, yeah, 320s. Yeah, yeah.
Bruce asked us to pass this around. If you'd like a copy of the slide or like to get in touch with us, use our sign-up sheet.
Yeah, we use the ZL version, so 8200 ZL. Yeah, it's been a pretty good switch. We've been pretty happy with it. Took some time to program though. No, no. Yeah.
For those of you in the room that think about it, if you go with Cisco and you're going to the AC, the older models, I call it Cisco Select LCR, the older models don't allow enough power for PoE for the newer racks, the AC racks. So if you're at Cisco and you're thinking about that, that's one of the steps you got to look at.
Good. Some of our PoE is provided by the HP switches. For some of it, we use the D-Sign, the power injectors.
Now, looking at your heat map also, are most of your dorms and like on that heat map, I saw very, very wide coverage. Are they newer buildings, older buildings? I mean, I'm working on a campus that is, from 1920.
You talk about here?
Yeah, that's pretty tremendous.
It is. Yeah, and it's. I'm glad you mentioned that.
Cinder block,
Mm-hmm.
multiple wires running through buildings of conduit over
Yeah.
and over again.
Well, it's interesting you mentioned that. Right here is the stage.
Okay.
So we're, believe it or not, we're wanting to put some access points here. So
The left end there does have some cinder block, but this
Yeah.
building was built in the mid-90s.
Okay. Right, right.
We're also deployed on cruise ships, which is the full head steel.
Yeah.
In our residence,
So Royal Caribbean is deployed AC for the Polish. That is fine. So, yeah, you make it work.
residence halls, the hallway dorms, I'm supposed to say dorm, the hallway space, residence halls, it's 1 AP for 6 rooms, so it's in the center, 3 rooms on each side. We have some unit-based dorms, and there's 1 AP for 4 rooms. And that seems to penetrate the oak doors and the cinder block fine.
Now, I just got a lot of wireless questions. I'm sorry.
oh yeah.
I'm from Clemson University, by the way. We average about 50,000 connections a day. Your lease time on the wireless, what is that?
Okay, so that was an issue. There was actually to a point, and when I was telling about the statistics and we had to do something, our lease times were every 20 minutes. Now they're, I'd say, 7 days. Yes, because now with the adjustments that we had to make, we have now 16,000 IP addresses. So if you have 3,000 students, 3 devices per student on average. So I think we're going to be okay. For you, it sounds like a much different situation.